Welcome everyone. In this video, I'm going to explain the linear expansion, or it can be a linear contraction. When a material or when a rod is heated along its length, it expands. Also, when it is cooled down, it contracts. So we can have the increase or the decrease in length. The term linear expansion refers to the increase in length of the material due to temperature change. So temperature change can cause a material to expand if it is heated up. If it's cooled down, it can cause the material to contract, that is to reduce along its length, to reduce in size. Now, factors that are used or factors affecting the linear expansion. The expansion of a rod depends on three factors. The first factor is the type of material. It depends whether you are heating, is it an aluminum, is it a steel, what type of material was being heated. So the type of material is alpha, is this symbol alpha. The second factor is the rise in temperature. Rise in temperature is delta T, the same symbol we're using in heat of a substance. Number three, the last factor is the original length, which is LO. So it depends on these three factors. These three factors, they affect the increase. So the symbol that we are using for increase in temperature is delta. The same symbol we're going to use for increase in length, it will be delta L. Have a look at this. Three factors, they affect delta L, increase in length. It can be increase or decrease. Equal to, it depends on the original length, type of material, and rise in temperature. So this formula will be given in exam. The first factor is original length, type of material, rise in temperature. Now, this alpha that you see, the new concept to you is called the linear coefficient of expansion. Linear coefficient of expansion refers to an increase, which is delta L, in length per unit length, which is the original length, per degree rise in temperature, which is delta T. So linear coefficient of expansion, the symbol used is alpha. When you make alpha the subject from this formula, you are going to have something like this. Alpha the subject, you divide both sides by LO delta T. So alpha would be equal to delta L divided by LO delta T. So this is the alpha. SI unit of a change in length in general is meter, divided by original is also in meter. Change in temperature is degrees Celsius. M cancels out M. So the SI unit of linear coefficient of material is just per degrees Celsius. You only left with per degrees Celsius. So these are the SI units. It will be whatever value you're going to get, then you say per degrees Celsius as SI units. This linear coefficient of expansion is a constant value unless the question says determine the type of material, then it can be the unknown. So you use the table to get this linear coefficient of expansion. It is found in this table. Linear coefficient of expansion of steel, expansion of copper, expansion of aluminum. So these are the values. You just, if a question tells what type of material is that, you come to the table to get the value of alpha. The linear expansion, example where it is the advantage and where it is a disadvantage. The mercury thermometer, it expands when heated in order to indicate the temperature, so it is an advantage. Also, when securing the parts to ensure a gas-tight seal, it is an advantage. Electric switches and thermostat, metal expands when heated in order to switch on and off. Automatic choke by metal string is used to operate the choke valve. Machine parts, rods and valve expands when heated. Heating can ensure that the valve will seal properly. So it is where this expansion is the advantage. Due to this advantage, when the mercury expands, we are able to read the temperature. So it is an advantage. Example where it is a disadvantage. The railway lines, when it is extremely hot, the railway lines, they tend to expand. The pipeline, the steel and concrete bridges, the telephone and electric wires, the boilers. So when they are too hot, they expand, or the pipeline, the sag will be down. These are the examples where it is a disadvantage. Understanding the length. So when we have a rod with its original length, this is LO. If it's heated, it's going to increase to this point, and this will be delta L. LO is the original length at normal temperature. Delta L is the change in length or increase in length. LF is the final length at extreme temperature. Let's have a look at this. We can have the increase or we can have a decrease. So if it is heated, it will increase in length. So this is heating. This is heating, and this is cooling. So if it's heated along its length, it's going to extend. This is LO, which is original length. And this space here is the delta because it's the increase. But from here to here will be the final length, which is the new length. LF, which is this distance, will be given by this one plus this one. So LF is LO plus delta L. But if it's decreasing, that means it's coming from bigger dimensions to smaller dimensions. So it will come from its original, which is LO, and this space here will be delta L, and it will end up having a small size or a shorter size. Now this shorter length will be LF. When you make LF of this one, the subject, LF will be equal to bigger length, which is LO, and this one is minus, because to get the LF is this distance minus this one. So it's minus delta L. We can conclude and say, if it's heating, to calculate the final length, it will be LO plus because it's heating. If it's cooling, it's LO minus change in length. And to calculate change in length, this is the formula. So this formula will be given in exam. Let me show you the formulas that will be given in exam. Formulas that will be given in exams. Linear expansion. Delta L will be given, which is for a change in length. Final length is LO. There is plus or minus. So the two formulas of heating and cooling are now put together in one formula in exam. If it's heating, you take plus, but if it's cooling, you take minus. So formula will be given. Now let's look at the work, the example or the activity. This is taken from a question paper of November 2012. A copper rod with a length of 5 meters and a temperature of 20 is exposed to heat with a temperature of 400 degrees Celsius. Calculate the change in length of the rod in millimeters. So the unknown here is delta L, but this delta L must be in millimeters. Now let's have a look at this. Formula for change in L, delta L is equal to LO alpha delta T. So if this LO is in millimeter, you multiply by the SI unit of alpha is per degree Celsius. You also multiply by temperature, that is degrees Celsius. This cancels this one. So if your LO, you fix the SI units of LO, you're still gonna get your answer in millimeters. Now, in this question, LO is given as 5 meters. And you are also given temperature of 20 and 400. So T1 is 20 and T2 is 400 degrees Celsius. It's copper type of material. So we're gonna get alpha from the table, linear coefficient of expansion of copper. Linear coefficient of expansion of copper is 0, and there are 4 zeros in front. So alpha is 0, 1, 2, 3, 4, 1, 7 per degree Celsius, the SI unit. Now let's go to the question solution. Formula is delta L equal to original times alpha times delta T. So if we just fix the original, there's no need to convert the final answer. You can also convert the final answer. Original is 5 meters. If you still remember, King Henry died miserable death called Metz. This is a basic SI unit, which is this meter, where this meter belongs. So you want to change it to millimeters. You move 1, 2, 3. So you multiply by 10 to the power number of times moved. You're going to multiply by 10 to the power 3. So 5 times 10 to the power 3 will be 5,000. Multiply by this, we got it from the table, is 0.000017. Multiply by change in temperature is 400 minus 20. Then you use your calculator to get the answer. It's 5,000 times 0.000017 times 400 minus 20. It's 5,000, which is 5 times 10 to the power 3. Multiply by 0.0017 into 400 minus 20. The answer is 32,3 millimeter. 32,3 millimeter, because this one is converted to millimeter. That is the answer. You can also use 5 there. If you use 5, your answer will also be in meters. So when you multiply by 5, the answer is 0,00 is 0,0323. Now you change this answer to millimeter, you're still gonna get this answer. Let's look at the second example. I'll do the second example on the next video. Thank you.